Thankful that some of you have come in. So hopefully we can start doing more of these as interest picks up. We really love the community. We used to do, how many, show of hands, how many people have attended an H2O meetup before COVID, I guess? Okay, quite a few folks. So yeah, so we want to start pick this up again, and if, assuming there's interest, we want to do more of these. So a lot of you have used H2O, I suppose. How many of you know us for our H2O open source or have used Driverless AI? Show of hands. Okay, Daching has used Driverless AI, and he's used H2O. A couple of folks. So let's start a little bit of intro, right? So if you've never known H2O before, brief history of the company. We've been in business for about 10 years now. So I think we founded in 2012. And for a lot of folks, they know us for what is called H2O-3 over here, this thing. For many years, this is the only product we had. This was one of the first open source machine learning libraries that was built to run on scale. So we could actually handle like terabytes of data very easily on commodity hardware. You could spin up like clusters on the cloud, on-prem, run it on Hadoop, run it on top of Spark, you name it. And it was 100% open source, still is 100% open source, and very widely used. I think we estimate that over 25,000 organizations around the world and maybe millions of users probably using the library on a daily basis. Very popular. So from that point on, though, in the last sort of about, I want to say like 4 or 5 years ago, like 2017, 5 years ago, we launched our first commercial offering. It was called Driverless AI, which was basically an AutoML product to do end-to-end machine learning from feature engineering, model building to interpretability, all in a machine. And that has been very popular, won lots of customers, a lot of users. And in the last sort of 18 months, well, coincidentally during the time of COVID, I suppose, we expanded ourselves to build an entire platform. So if you haven't talked to us in a while or you haven't seen us in a while, today this is what the company does. So we are an end-to-end machine learning platform. We call it the H2O AI Cloud, where we have obviously some of the best tools for doing machine learning, data science, which is including H2O-3 and Driverless AI. But we also built a whole series of suite of tools around operationalizing machine learning, deploying models to production. We have an entire app store full of applications, which if you haven't seen, I'll show you in a second. And we also built some really cool solutions for deep learning, like hydrogen torch, and we have a document AI product for doing OCR and intelligent document processing. We also have a feature store, which is basically helps sort of operationalize more information. So it takes care of all of your features, puts it in the store, and gives it a time of scoring and time of training as well. And finally, we have H2O Wave, which is an open source low-code app development framework. That was also released in the last 2 years, and that's used to power a lot of these apps that we'll talk about today. So in a high level, if you think about what does the flow look like, what do all these things matter? Like, why do those things matter, right? So if we think about essentially the data science workflow, or even like the machine learning AI workflow for any organization, and we think of three sort of high-level things. You want to make AI, you want to operate on AI, and you want to innovate/consume the AI. And how do you do that? When you talk about make, we are talking about the steps that go into actually building machine learning or data science models. And typically, you start with feature engineering. You start with bringing raw data in, doing some EDA on it, doing some analysis, visualizing the data maybe, looking at patterns, and then doing some feature engineering. After that, you go through your model building process. This typically involves running AutoML, maybe doing forecasting, choosing different libraries maybe, using different techniques, building models essentially. Once that's done, there is another important component, which is about explanation and interpretation of those models. This becomes more and more important, especially when AI becomes more mainstream. It's not just enough to build a really accurate model. You got to explain it. You got to understand why the model is doing what it's doing. And to do that, we have a whole suite of tools for interpretation, but we also have ability to create models which are inherently white box, which are inherently transparent. And then we have tools to find and detect bias. And then we are working on other things to help you and then mitigate some of these issues that you might have had in models. And finally, that's done. How do you consume these models? To do that, what we found is that typically you take a model, you put it into deploy it as a REST endpoint or do like a batch scorer. So that's just one part of it. But when you talk about how do you do this at scale, you start thinking about, okay, it's not just one data scientist building one model, but the team of data scientists coming together and building models. Then you need to create tools for collaboration so that models can be registered. They can put into a place where you can manage those models. You can have workflows for approving it, reviewing the results, and then deploying them. And once you deploy the models, you want to then monitor them to see if the models are changing over time, and then use that information for retraining. And then finally, how do people consume these models? So the final outcome of that is like business users or end users, even sometimes end customers of these models would be people who might be using them to make predictions or making decisions. And to do that, you need a whole suite of tools that translate the models into business context. So we have built essentially a low-code app development framework to build these applications. And we have a suite of these applications, and we have an entire app store full of apps. Some of these apps are data science apps. Some of these are vertical apps. Some of these are more solution accelerators that help you to do certain things. All of this combined is basically H2O AI Cloud. So when you come to our website today, go sign up for H2O AI Cloud, a free trial. You have a 90-day free trial. You can go sign up, and you can access the whole cloud. And you get all of this. You can play with the entire thing. But while we're doing this, one of our sort of core tenets around this is that we want to make sure that this platform is still open and extensible. That's our roots. We are an open source first company. We want to make sure that anyone can add more of their components. So we're giving a suite of tools, but customers and users will come in with their own things. You can add your recipes, add your tools, add your apps. We want this platform to be flexible and scalable. That's the promise we want to make to you. So while you trust us or you build your data science workflows or machine learning on this, we'll make sure that this platform can scale. It can work very nicely with existing ecosystem. And more importantly, finally, this is trusted and secure. So we have spent a lot of time as a company ensuring that all of our tools are built in a more secure fashion so that it passes all the great enterprise-grade checks. Also working towards making sure that we pass all compliances, going through SOC 2 compliance or HIPAA, PCI, those are things that we're working towards. And more importantly, everything we create, any machine learning or AI or data science you do, you want to make sure that that is trusted. You want to give you the trust that this is the best model that you could produce. And you can then give the trust to your end consumers who might be business users or your regulatory or your management, whoever it is. So that's H2O AI Cloud. Now, how do people consume it? So this is just the same view, but in the form of an architecture. And I'll talk about some of these pieces in a second. But really, we built this H2O AI Cloud, and we offer it in two forms. The first is on the left. We call it the hybrid cloud. And that essentially lets you take this entire AI cloud, run it on-premise or on your VPC, wherever it may be. If it's on one of the big clouds, we can run on inside the big clouds. Or you can run it on-prem as well. All you need is Kubernetes, right? And it gives you full flexibility, full customization. It is running in a secure environment, so no data leaves your premises or your network. So it's very secure as it gets, as secure as your network is. We also have a managed cloud offering. So if you want to just say, hey, H2O, please spin up a cloud for me, turnkey, almost like a software as a SaaS solution, software as a service solution, SaaS solution, that's the managed cloud. It comes again, it's built to be highly secure. Every customer gets their own single tenant. There's no sharing of resources. It's all built to be very secure. We take care of all the operations, all the migrations, everything is taken care of by us. You can just come in and start running your workloads. All this is built on top of Kubernetes, so the entire AI cloud is built to run on Kubernetes. We take care of a lot of the abstraction layers for you, all the work around telemetry, authentication, storage, collaboration. All those pieces are taken care of. We take care of it. We give you you get it for free when you run the platform. And you get all the layers on top. So this is where you would interact. You come as a user. You can use one of our what we call AI engines. This is where you can start building models. You can use H2O-3 if you want to do big data at scale. You can use Driverless AI if you want full automation. Hydrogen Torch lets you do deep learning in a no-code fashion. Without adding any code, you can get really sophisticated models. Document AI allows you to go through your physical or real documents and then scan them and do analysis on that and build models to read them. You have MLOps, you have feature store, and then you can access it through a whole suite of apps. We also offer the Wave SDK. So you can use it through Python or Scala or one of the clients we support, or you can go access the GUI directly. And then we have notebooks as well. Okay, I'm going to jump in. So originally we had planned for this meetup to be in sort of a repeat or like a recast of a recent product day event that we did recently, where we announced a lot of new updates to the platform. But I just wanted to see if folks want to see the new things, or like are everyone familiar with the AI Cloud, or would it benefit like basically a redo of like the AI Cloud itself? People seen the AI Cloud? Do they know what it is? Or would you like to see just a demo of that?
I'd like to see a demo.
Okay. All right. Okay, so why don't we do that? So since like a lot of folks haven't seen this, we'll just maybe start with a demo of the cloud itself, so you can see what you get. So start with showing you where you can go get access to it, right? So if you go to our website, H2O.ai, click on Get Started, fill up this form, and you fill this up, you complete it, you will then get kicked into something like this. This is the H2O Cloud, and you'll get a login, you can sign in. I'm going to sign in over here. Okay. This is very secure, so as you can see.
Clear 10H charm. It only worked on Chrome for me earlier, to be honest with you.
It did? Okay, this thing?
Yeah,
Okay. Well, I have this is our internal cloud, so I've logged into this. So I'll just show it over here. But you guys can sign in and you can get to cloud access. This is our own internal version of the cloud. So I'll just walk through this very quickly. So when you come in, you will basically see essentially a bunch of apps. This is the App Store, right? So you have a lot of applications. Some of these are related to like exploratory analysis. You'll see like apps like we have one for model validation. This basically you can upload a model and it runs a battery of tests on that model to see if the model is good or not. The applications for connecting with Snowflake and doing some work. We have like AutoWiz applications, data profiling applications. There's a whole bunch of machine learning related applications, right? This is some of it we talk about today, like hydrogen torch and Driverless AI. But there's other things and a lot of new concepts that we're introducing. Some of these are all available over here. Have a bunch of explainable AI apps as well. These kind of help you explain your models, understand the results. And then we have a lot of vertical apps. So if you, for example, if you go to the healthcare tab, you'll see a lot of apps. These are built to solve specific problems for healthcare. Similarly, we have some for manufacturing. We have some for retail, marketing, and so on. And we continue to add a lot of these applications and make them available. So these apps are all built with our Wave SDK, right? So let me just show you an example of what it looks like, right? So I'm going to pick, yeah.
Are these built by clients or by H2O or a collaboration?
Yeah. So great question. So most of these apps are right now built by H2O, but a lot of them are built with collaboration with clients and customers. And we also have a bunch of community-built apps as well. I'll show. We recently ran a hackathon / challenge called for wildfire prediction, and you got a bunch of community apps. So I'll show some of those apps as well. All right, so this is an app we built for one of our hospital customers. Large as part of when COVID was on, they wanted to build a hospital simulation app. So what this basically does is it lets them basically very quickly pick their county and pick their state, and then lets them simulate what the ICU and non-ICU occupancy is going to be for the next few days and weeks. And this is using real data coming from, let's say, public data sources for COVID cases, and we just use this. So a lot of hospitals are now just using this directly, and we have this free of charge as just as part of our AI for Good initiative. And this entire application is built with Wave, right? So I can basically personalize, like based on this. Let's say I'm a hospital, my average admissions are going to be 180 per week, and pick this, and they can apply Go, and this will basically change the simulation. Right. So just an example of an app that we built, and we put it up for customers. Go back here. There's ones for like cytopathology. This is one which I like. Take a second to run while it.
What does it take to build a Wave app?
Yeah, so great question. So Wave apps are meant to be. So let me show you what Wave itself is while this is pulling up, right? So this is the low-code app development framework that is used to build all of these applications, right? It's basically you can write your applications in Python. Data scientists can write it without having to write any front-end code. So it's built to be super easy to write. And you have a lot of scaffolding to get started with. But you can write really rich applications without having to know any front-end. All the front-end work is taken care of for you. You just have to define the logic, and you can build rich applications. So it takes like anywhere from few lines of code, like tens of lines, and sometimes like very complex applications. I'll show you some of those. And we are dogfooding ourselves. So parts of the platform are built in Wave itself, but you can build really rich applications, interactive applications, all using Wave. So this is another one that we built to predict like number of infections and compare cohorts. Can compare over cohorts of time and see all the differences. So these are, like I said, some of these applications we built in partnership with our customers who are either hospital networks or insurance companies. So, okay. So when you come in, you'll get something like this. You'll start off with like, this is also your cloud console, right? You just come in to start off your work. You can obviously start with running H2O ML or Driverless AI, which is again our AutoML engines, and I'll show this in a second. But you can also then start doing other things, like you can run analysis. You can do some like there's Auto Insights, which lets you run take a data set and then run a bunch of insights automatically to show you value. So I'm going to kick off some of these, and then since you folks might have seen it, we can look at that in a second. Okay. I'll let that run. And as those are running, you'll see them or come over here. So right now it's not available, it's kicking it off. When it finishes, you can see that the app is running. I can go and visit that one. Okay. And then also I'm going to go to my notebook instance over here. Okay. Yeah. So that's in a high level what the H2O AI Cloud is. Now, let me show you a couple of some of the new things that we have in a way invented or added in the last few. Oh, and then let me just show one other thing. You also have at the top, you see My AI Engines. This allows you to launch H2O and Driverless AI. These are AI engines for building models with AutoML or H2O open source. And it's very easy to launch these models. You come in, you can basically launch an instance by picking your profile, then giving it a name. Pick the version of software you want. Typically, you'll have the latest version available, so you can just use that. Pick the number of CPUs, GPUs you want, and then you can leave everything by default. Just add more CPUs if you need to. If GPUs are available, you can use them as well. So I'm just going to launch one instance very quickly over here, and it'll come up in a second. So that's how you launch. That's as easy to launch a driverless instance. Same thing I can do. I can go to H2O and I can launch an H2O cluster very easily. You can specify how big the cluster you want to be.
So this could be an AWS or?
Yeah, this whole the cloud can be running on AWS, Azure, or GCP. Yeah. If you go to the cloud at H2O.ai, that is all managed by us. That's running on AWS. And you can just come and launch and use all of these things. Okay.
And then in terms of the usage, pay by time or subscription or?
Yeah, so we still sell enterprise licenses. We charge by the basis of capacity. So how much compute capacity you want the AI cloud to be running it on. So customers can buy, let's say, some number of compute units. We call them AI units because you can use the same compute for running driverless H2O or MLOps or running apps. So you don't care. It's okay. It's up to you what you want to do. So you can run any workload there. But you can get the entire cloud and pay by the computer capacity that you need.
So the license fee and the machine server costs are sort of bundled together.
Yeah, so if you run the managed cloud, that's exactly right. So if you go sign up for our managed cloud, you come to our cloud, you sign up, everything is bundled. So we take care of the hardware costs and the infrastructure costs, and you pay a flat fee per unit. And if you need more, you can ask for more units. You can basically, depending on your needs. If you do the hybrid option, then you're always going to be running it on your own servers. So then you bring the hardware, but you just buy the software. But you pay the software cost only at that point.
Do you support autoscale?
We do, yeah. So the entire cloud is built to be autoscale. So let's say I launch an instance. Let's say you load it out in an organization. 10 data scientists come in. They all launch instances. And if you're running out of capacity, it'll autoscale and spin up more Kubernetes pods for you. Yeah. So I'm going to launch a H2O cluster as well, just a simple 2-node cluster with 4 CPUs each, and then maybe 16 gigs of memory. Launch this. Okay, we'll let both of these launch. So my driverless engine instance already launched. I can click on it. And just like that, I'm logged into it, right? Once I'm in, I can pull in data from different sources, and you can configure. You can add other additional data sources as well. So what I'm going to show you is a simple way. This is something called H2O Drive. So let me just show you what H2O Drive is real quick. H2O Drive is your sort of one single place, one sort of way to bring in all data sets that you need for anywhere in the cloud, right? So this is kind of your sort of S3 bucket on our AI cloud, so to speak. So come in here, there is already a demo datasets folder. And all these datasets are available out of the box. But I can very easily add new datasets. I can also connect to a whole bunch of data sources that we provide. So you can pull data from, let me see, make it a little bigger. You guys can hopefully see it. You can pull from S3, Redshift, Snowflake, Azure Blob, so and so. And we have like support for over 150 connectors if you need to. So all common enterprise data sources are all supported, right? So in this case, since the data sets are already here, so I'm not going to import, but it's very easy for me to add new data sets from here, right? I can also upload a local file. But let me go back to my driverless instance, and I can now read from the H2O Drive. The demo data set is showing up, so I'm going to pull that up, and I'm going to pick one of these data sets, okay? And then I'm going to import it. All right, it shows up over here. You can see the data set is now here, and I can start then building models over here. I'm not going to go through a demo of driverless AI since there's many tutorials for that, many demos for that, but I'll just show you quickly the new features that have been introduced recently. Okay, so I'm going to hit predict. Oh, let me go split the data set. Let me split it into train, test. Just going to do 80-20 split, and then save it. All right, I'm going to take train and then build the model. So in this case, there is a bunch of data about houses, and we're going to predict the price based on all the data about the houses. For folks who haven't seen driverless recently, we also add a new unsupervised tab. So previously, driverless was really good for supervised learning and can handle all kinds of whole bunch of use cases. But now we also have unsupervised learning, and we support a bunch of different techniques. We have isolation powers, k-means, truncated SVD, and so on. So these are available if you haven't seen them recently. Okay, we'll go back to supervised. I'll pick my test set over here, and then I want to point out a few things in the expert settings. So there's a whole bunch of things in expert setting. I mean, you don't need to do any of this, right? So if you are coming in for the first time, you can just trust the machine, hit launch, and it'll start building a bunch of models, right? But I want to point out some of the, so what we've done is we now, of course, offer a ton of functionality, like, you can configure which models you want, you can configure which features need to go in, and so on. I want to show the recipes real quick. So for folks who haven't seen this, we have over 250 open source recipes. So driverless AI is basically an amazing fast machine that does a lot of optimization and tuning for you, but you can bring in your own models. You can bring in your own feature engineering. You can bring in your own scorers if you want to, right? So there's a whole bunch of things you could do. You can do a lot of data prep in it, for example. You can write recipes to do data prep. You can do, if it's unsupervised learning, you can add your own algorithms, for example, for unsupervised learning. Same thing for NLP. We have a lot of explainers now. So when you get to the explanations of the models, you'll see how you can extend that as well. And of course, you have a lot of scorers, models, and so on. So everything you see in driverless AI is fully extensible, right? So if you remember when I talked about, well, for core tenets is platform needs to be flexible and extensible. So you have full control what you can do with this. Okay. So I'm going to cancel out of here and then hit launch experiment. And we'll see what it does. Okay. And I'm going to let that run for a bit. Then I go to H2O and open it up. Okay. So this good old H2O, for folks who remember, flow is here. I can, and you can go and see how this is running. I can go look at my water meter real quick. You remember we launched a 2-node cluster, so it's showing up. Both the clusters are up. Good, right? So some of the things we added in H2O itself, I want to talk about that real quick. So for folks who don't know, H2O is distributed in-memory machine learning for big data, right? Fast and accurate. It has R and Python APIs. You don't have to, and the nice thing is you get basically a really fast mojo. This is our model deployment artifact that you get out of it for free. Now, what are the new things we added? So H2O has a bunch of new algos now. We recently added something called as distributed uplift algorithm. For folks who are not familiar, basically that allows you to do interesting things like model out what a change in treatment for a certain group will lead to. So this is very useful in marketing use cases, for example, when you're trying to predict if you're doing a churn use case and I want to see, hey, what happens? What kind of offer can I give a group of people that will help me improve their outcomes? So uplift modeling is very useful for that. So we have a native uplift algorithm built on top of the distributed random forest. We also have now rule fit. We have added rule fit for a while, but we added it for multi-class problems. So for folks who are not familiar, rule fit is a really nice algo. It gives you simple, human understandable rules. And that's really useful to tell if you want to make decision sciencing or give business users an outcome that they can understand. Rule fit is really nice. We used to only support.
Are the rules displayable, or you can see?
Yeah, yeah. You can download the rules. So you can call the Mojo and get rules as well. So you send them a score, it give you a prediction, and it'll give you the rules as well. So it's nice. We also have a bunch of options for pre and post modeling. So we have added some automatic feature selection, and then we also added a ton of explainability functionalities as well, right? So this is something that used to be available only in Driverless AI, but now it's available in open source. We have about, I think, 8 or 9 different techniques now available. So you do H2O.explain, you get a bunch of different techniques. Yes.
So in terms of feature engineering,
Yeah.
We used to do this as sort of, sparkling water,
Right.
or hard, or some different.
Yeah.
Are they new ways of generating, features?
Yeah. You've seen the driverless ones, right?
Yes. Driverless AI automatically generates
Yeah.
a set of recipes.
Yep. Yep. Those features are available. One of the things we also can do is we can give we call it a big data recipe. So we can basically create a recipe for H2O open source now out of that. So from the driverless feature engineering, those features can be translated into a big data recipe that can be used to run on H2O. And you can then get the feature engineering from driverless and run on scale for H2O. So that's possible now. So like I said, this is the Uplift model, which is useful to figure out, like, for example, when you're trying to take a bunch of users and want to apply different treatments to those users, you can find out what will happen when I apply a certain type of treatment for a certain group of people, and you can model that very accurately. And rule fit, like I said, you can get text to it directly in the form of business rules. For feature selection, like I said, we have now find the strongest predictors. We have 2 techniques, one called infogram, the called model selection toolbox. Both of these tools, and you can pick which one you want to use for feature selection based on all the features you input, and they give you, they're pretty good. They have their own pros and cons, but both those options are now available for H2O-3. Like I said, explainable AI, we have all these different techniques available now. You can run it, and then you can get basically the global model explanations and also the local explanations. Okay. I want to share a couple of. So if you want to read up a little bit more about the distributed uplift model, you can read up. It's in the documentation. There's a very nice notebook as well that explains how to use this if you want to try this out. So you can use this sort of similar to causal ML. You can basically do an analysis and run this and see how a distributed model will look like and see if the uplift will work. Okay. All right, back to this. The next product I want to sort of talk through for folks who have not seen this before is called Hydrogen Torch. So this is a very new product that we launched, I want to say about like 3 months ago, so fairly new. So basically allows you to take unstructured data. Unstructured, we primarily are looking at text and image data. We just recently also had audio. So image/video, and then text, and then audio coming soon. And then you can build state-of-the-art deep learning models, and you can do this without having to write any code, right? So it's basically user interface built for no-code deep learning. So it's extremely easy to use for anyone, and we have we offer multiple levels as well, depending on your expertise, whether you're a novice or if you're an expert. If you're a novice, basically you're letting the software do all the choices for you and still get a good model. But if you're an expert, you can obviously tweak different things. You have a lot more options. We have dramatically expanded the number of problem types that we can solve. So with Driverless AI, previously you could only do basic classification or regression, but now we can do a whole class of problems that we couldn't do before. So these are all now available out of the box. This is also one of the first products that has been built with a lot of input, or actually primarily built by our Kaggle Grandmaster team. Right, so a lot of the best practices from our Kaggle Grandmasters have gone into it. So those best practices are now available directly for end consumers like you for deep learning. And it's easy to deploy. More importantly, all the models we create, we have a one-click deploy or a very easy way to deploy them in your envelopes too. Okay. So H2O still has a lot of different problem types. I'll show them in a second to you, but we've added a whole bunch of different techniques there as well. So why don't I show a demo of hydrogen real quick? All right, I'll let you launch for a second. And while that's coming up, let me just see if my driverless model finished. It did. So this model finished. There's a lot of functionality. I mean, won't go through all of these. You can obviously interpret the model. You can visualize the scoring pipeline. This is nice. It gives you a full pipeline visualization. Oops. You can see what's happening at each step. You can go as deep as you want. It gives you full visualization of what exactly driverless is. So you can see this is all the transformers it ran to build the model, a LIGV model, and then create the output, right? One thing I want to just show, we also have this notion of, this is a new thing that we added. This allows you to basically create a recipe So what I just did is that pipeline that you saw is now exported as Python code. So now you got this really good AutoML pipeline exported as Python code that you can publish into Notebook, or you can put it into Git and you can rerun again. So you can basically have the entire logic for the model that driverless figured out, all the features it did, all the transformers, all the models, all as Python code. And this is really powerful because now you can go change it. If you want to say, I want to change the feature engineering, you can go tweak it yourself. You can do your own things, and you can then save it. So you can make it your own. Let driverless do the first cut, take the output that comes out of it and do your own. So this is something that we recently added. And then, of course, you can add it as a recipe back into driverless, so you can run it for future purposes. There's also a nice way to collaborate. So if you build a nice, really powerful set of features, you can then give it to some of your other users in the company and share it with them. Okay, cool. And then I'm going to do one thing. Okay, I go to projects. I'm going to create a new project. Meetup. And then I'm going to link the experiment that we just ran. Oops, that didn't work out. I'll take the data set in. Well, it's not an issue. Well, let's go to the one we already have over here. So this is a project that was shared with me by someone else. So in this case, these are not my experiments, but I can import these experiments. So I can basically import these, and they'll then show up in my environment. So for folks who haven't seen before, collaboration for data scientists is always a challenge, right? How do you you have to send big models, people, or give them notebooks. Of course, in the world of AutoML, how do you do that, right? So what we have done is essentially create this concept of projects, and we had this for a while, but we now made it really simple to use, where we can build models and share it with each other. And I'll show, when I go to MLOps in a second, you'll see how powerful this is, because now I can deploy models or share models with my ops team as well through the.
So is this driverless AI, or this is a hydrogen tool?
This is all driverless AI. We'll get to hydrogen in a second. I just waited for the experiment to finish, right?
Oh,
Yeah. Yeah, sorry, I'm going back and forth, so pause me if you have any confusion. Okay. Yeah, so this is all here. I can, of course, import the data set as well if I want to, the whole experiment. Yeah, and then I can compare the two models really quickly. You can see the performance of those models. It'll show you side by side all the scoring charts and history. Yeah. these two.
Reporting the data sets, how is it in memory or will it be in memory?
Great question. So this is there's a concept of shared storage. So the AI Cloud has a shared storage layer where you can share artifacts from. So that's where it gets stored. So when I push it to someone or share it to someone, it goes to storage, and from there, it's like kind of like a Google Drive for your AI Cloud. And from there, you can then share it with people, right? Once I have it over here, I can basically give access to this thing to other people as well. So if I do,
But the data sets are on disk or in memory?
the data sets are on disk. Yes. Yeah. There's,
Physically or is it linked?
what's that?
Is it physically removing it to some machine or is it?
It's yeah. So this is all Kubernetes, right? So what it's doing is basically there is this volume that gets attached to every pod, but the volume itself stays on. So pods can come in and go. So let's say after I finish my experiment, I pause my instance, my compute can go away, but the volume will stay. So I can then launch it back. The driverless instances, H2O instances, are meant to be ephemeral. So you launch it, you run experiments, you shut it down. But when you push into storage, that'll stay on forever. So that's basically a shared storage layer that's basically physical storage, but is persistent across your cloud. And even when AI engines can come up and down, but your storage will stay. Okay. All right, let me go back to Hydrogen. Okay, so Hydrogen launched, right? So this is what you get when you come to Hydrogen. Hopefully similar theme, so it doesn't, not too dramatically different. You can import a data set, you can create experiment, you can inspect and deploy. This is kind of the workflow. We'll pick one data set that we already have preloaded. This is a simple coins data set. Basically, this is a Kaggle data set, I believe, but a bunch of images of coins. And the goal is to use deep learning to figure out, machine learning to figure out what is the value of sum of all the coins together. So just by using the images. So we can see a nice visualization of the images themselves. So what you can do some summary statistics as well. You can see how many labels are there, how many data sets, and some summary about that. So let's go create an experiment. So when I come in, I have a lot of options. So for the basic, by default, it's picking something that's a skill, right? So let's say I'm a novice. I don't know anything about this. I want as much automation as possible. So the data set is loaded. The problem type, here we have a bunch of problem types, as you can see. Let me make this a little bigger. We can do, of course, image classification, regression, metric learning. There's instance segmentation. This is a new technique we added, object detection. These are all image techniques. Then there's a bunch of NLP techniques as well, like semantic segmentation, text classification, metric learning, sequence to sequence, span prediction, token classification, so on. Yes, that's it.
So I see, is Hydrogen Torch a separate module from Driverless AI?
That is correct.
The UI seems similar.
Yeah, they're similar because we want to have people feel comfortable, but yeah, it's a different module.
Different module.
But it's part of AI Cloud, so you come to AI Cloud, you get access to all of them. Yeah. So.
And why would we use Hydrogen on Driverless AI?
Yeah, no, so great question, right? So like I said, if you do driverless AI, you have some image classification, but you can only do image classification and regression. That's it. Those are the only two techniques supported in driverless. Same thing for text. We can only do text classification and regression in driverless, because driverless is really built for basically classification and regression type of problems only, whereas Hydrogen is built ground up to handle all kinds of unstructured data problems. So we have an opportunity to do a lot more than we could do before. Over here. Okay. Then you can put all the information about the things. So the nice thing is we have now a bunch of pre-trained networks that you can take advantage of. So we call them backbones, but we give you a whole bunch of backbones that are preloaded, right? So depending on the model type you pick, all these backbones are preloaded. These are pre-trained networks that we ship with the cloud. So you can just pick which one you want and start training off of it. If you don't pick anything, it'll pick a nice default for you, but it's totally up to you. And then same thing, we have a lot of scorers. You can pick which scorer you want. And that's pretty much it. I can then go run an experiment. So maybe let me do this one, leave everything as it is. I'm going to run an experiment. And we'll let this run for a bit. Okay. That's correct. So these, I mean, they can run on CPUs as well. Obviously, it'll be super slow if you run on CPU. So Hydrogen Torch is, it's recommended to run them on GPUs to get really good performance.
So on the cloud computing platform, it's already plugged in.
Correct. That's right. So when you set up on your own infrastructure, we can then configure it for you. So then you can put the right set of GPUs, how many ever GPUs you want. So you can also control. You don't want to run a big cloud now cost, so you can configure how much GPUs you give per instance.
If I have a workstation that has a couple of GPU,
Okay.
1080s,
Okay. We have.
something installed there and just run my little.
Yeah, we have the option to install the whole thing in a VM. So this whole AI cloud, we can give it to you in a VM, and you can run it on a workstation if you want to. I mean, obviously you won't get auto scaling on it, but you can still run it and try some things. Yeah.
Quite part of the question is how much can you run with it, right?
Exactly. So you can. It's worth trying. Yeah, for sort of experiments, POC purposes, it's good enough.
How does this integrate? I have a Kubernetes cluster.
Yeah.
How would you integrate with an already set up?
Yeah, so if you already have a Kubernetes cluster, we can come and install the AI Cloud, and it's basically we have multiple options. We have a Terraform script that you can run, or we have Helm charts to go and install on your existing Kubernetes cluster. And once it's up and running, you will see basically a dedicated namespace for H2O AI Cloud, and that's where all of the workloads will run under. Yeah. Okay. This is still running. As you can see, already some metrics and performances you can see as the learning rates, how they're improving over time. You can see some summary, some training data insights. So in this case, it's starting to make predictions. In this case, it's predicting 10. This is 100. This is 55. So it's getting some right, getting some wrong, and it's trying to improve over time, right? So you can see all the results that are coming already. And you can see how the loss rates are. Okay. So in this case, it predicted 11.97. It was actual as 10. Here it was 10 was a label, and then it predicted 1236. This was a quarter. It predicted 28.52. So it's getting pretty good. It's already doing pretty decently, as you can see, for most of the examples. So it also gives you some, here we can see which are the best ones where it did really good, right? So these are good results. You can see which one are the worst ones where did it do really poorly. So you can see the images are really, like this one, the image is really dark. It's tough to even read what the coin values are. So obviously the the model did poorly as well, right? Same thing. So you can see what kind of images it's struggling with, what kind of images it's doing really well with. And you can use this to then improve. In the next iteration, you can also add some capability to do semi-supervised learning. So you can do some labeling as well. So as you see bad samples, you can then go label them, and then you can improve the model. So we're really excited with this one. This is extremely powerful. Once you're done modeling, you have a couple of options. You can hit predict over here, upload a new data set, and run predictions directly over here. So that's very simple, straightforward option. You can also download the scoring artifact. It's basically a Python scoring file. You can then use it to run it as a REST endpoint or run it elsewhere if you want to. And then we can also download an MLOps package, which lets us then deploy this into our own MLOps, which I'll show in a second. And that allows you to then deploy it as a REST endpoint in MLOps. Okay. So that's Hydrogen Torch, super high level overview. All right, let's go back to Claude. All right, so since it's almost 7:34, let's go and show. Let's say you built models. You built models with H2O or Hydrogen Torch or Driverless AI. You want to then go and deploy them, right? So to do that, you then come to our MLOps. So let me go to our MLOps. What's that? My models too. You can hit the My Models tab and get to MLOps. There you go. Yeah. I was going to show the new interface too, but yeah. So that's one way to get, and you can also come in from And we have a new interface for that same My Models tab. This is how it looks like it. So you can come and see those. So recollect in Driverless, we had 3 projects. Those 3 projects are showing up over here as well. So it's the same 3 projects you can see from MLOps. You can then go, let's look at this project. This is one that we, if you remember, we imported the artifacts, right? So this has 2 models already. The models that we saw there, you can view those same models over here. You can see the experiment ID, they'll match, trust me on that. You can go look at the original experiment as well. So if you want to go, let's say you're an ops person, you want to go, you just see, you don't even go to Driverless. You can come and view all the results over here. You can see what is the model built on, what data set, what is it using, what parameters were used, all the metadata about the model is over here. So even if you never log into Driverless, you can go see all the information. So imagine you as a data scientist built a model and shared it with your ops person. The ops person can review the models. Does everything look good? If so, they can then go and deploy directly. Okay. You can write comments back and forth if you want to. Right. And then I can hit take a model and basically create a deployment out of it. And that's already done. So I'm going to just show you the deployment over here. So this is a deployment. It's running, but it's very easy. If I want to create a new one, this is how I do it. I give it a name, demo deployment. I put some description. I pick, so in this case, it's single model. I can pick the model. I can select whether it's a real-time or batch scorer. If it's real-time, I'll pick it. I can pick the environment, whether it's dev or prod, and you can add more environment types as well. I can also put any additional parameters if I want to. I can pick security, whether it's high security, low security, so on. And I can put in other parameters around memory, etc., on Kubernetes parameters. I can also deploy, have multiple replicas if I want high availability for the model. Okay, that's all. Good. Let me go back. And once the model is deployed, I can then go look at the curl request over here. You'll see the model deployed, and it's a curl request, and I can run this, and I'll get the same results back. This is the REST partnering. And once the model is running, I don't know. I can go look at monitoring as well. It's show me alerts as if the model starts drifting, I'll start getting alerts over here. Okay. So that's a very quick overview of MLOps. And then finally, I'll just show one thing, which is something I personally like. If you are then running, let's say, a department and you have a whole bunch of people running stuff, you can then go look at what's happening across your organization. You can get a high-level overview of all the different models, all the different projects that are running in your organization. You can see how many people are running, how many models. You can see what models are deployed, how many of them, who's doing what. So get a nice high-level overview at an enterprise-wide level or org level. Okay. So that's pretty much a whirlwind of all the tools we have in our platform. There's a couple I didn't get to. I'll just talk through them really quickly. One of them is Feature Store. So how many folks are familiar with Feature Store or have used one, even if it's not H2O? Okay, that's you down, right? So at a high level, what Feature Store does is basically, this is again something that becomes valuable as you start doing enterprise machine learning at scale, right? So as you have a lot of users building a lot of models, a lot of feature engineering pipelines, you'll start seeing a lot of repeated work. People will keep creating features, keep deploying them. And each time you do that, you need to have some ways to manage them, right? So what feature engineering does is it basically takes all your feature engineering pipelines, records them, puts them into a store, and it keeps a cache. It keeps an offline cache for repeated trainings and an online cache for inferencing. And you define the pipeline once, and then you don't have to repeat those features again and again. So let's say you built a bunch of features for a churn model you built, and you created a whole bunch of new features. And all the work that's gone into creating those has to be done just once. After that, next time you want to use those same features again, or someone in your organization wants to use them, they can just go to the feature store and see what features are available. And if they use one of the features that's already in there, the good news is the pipelines are already built. You don't have to recreate them. And more importantly, they will be available at the time of inference. So those features that you use for training exactly will be available for scoring. So you don't have to worry about the pipelines part of it. So it's really nice when you have, let's say, a good sized organization and a lot of users building models. Feature store helps accelerate that tremendously. So this is available in the AI Cloud too. So you can come in. We have a whole bunch of pipelines that support. We have additional capabilities like we can now start recommending features. We can tell you when features are drifting over time. We can do automatic bias detection in your features if they exist. And then you can have all the capabilities like we can have search, discovery, a whole bunch of features, right? More importantly, we integrate with all the common pipelines. So let's say your data warehouse is in Databricks, or if you use Snowflake, or you use Teradata, it doesn't matter. We have clients for all of those data sources. You can ingest directly from those data sources, bring it into the feature store, and maintain it for each. Okay. All right. So that was pretty big whirlwind. Let me see what else did I leave. I'm going to touch upon a last thing, which I don't think we'll do a demo of this one, but I'll just quickly talk through what this is. We also launched a product called Document AI. This is a recent product, and this is another powerful product. What it does is basically it takes all kinds of documents. It could be images, faxes, forms, semi-structured documents, right? Any kind of document you can bring into Document AI. You can process it, understand it, create models out of it, so that you can then very easily do segmentation, entity detection, or modeling out of it. So whatever you want to do, right? And why? So this is not a new space. Right? There's a lot of vendors, a lot of tools that do it. We think this is powerful. What we have built is unique and powerful because what we have done is we have built it in a way that it can handle a lot of tough problems. So you will see some off-the-shelf tools that do really well with standard formats. Let's say a very standard format would be like a passport or a driver's license, right? We all have phones that like apps that can take a picture of a driver's license, tell you all the basic things, or credit cards, right? You have apps which can read the credit card number, right, from your phone very easily. So when the format is fixed, there are a lot of tools you can build a really good model, or you can know exactly what you're looking for. The problem is when the format is not fixed. I'll give you an example. We work with some of the largest hospital networks, and hospitals have a unique problem. They all get referrals from other hospitals all the time, right? And each referral looks very different because hospital A has their own format of sending a referral. Their document looks different. Their lab results look different. Hospital B has a different format, and so on. In the US, there's like thousands of hospital networks, and not to mention if you get to like this individual practice shops, there's like tens of thousands of, if not hundreds of thousands. Each of them has a different format. The data is still the same. They all have the same lab results. They all are talking about the same things, but the formats are completely different. This is where most document processing tools fail. Like a lot of the robotic RPA engines or a lot of the out-of-the-box solutions, they all don't do well when you have bespoke document types. And that's why we do really well, because we try to find out exactly so we can detect layouts very well, and then we can detect the entities. So we are combining, we call it ICR, not OCR, because it's intelligent character recognition along with NLP to give you a really strong model that can go solve these kind of hard problems where you're trying to get the same information but a variety of different formats. And what's nice is we also built essentially an engine to help train or sort of create labels very easily. So, and we built this so that you don't actually need to read a lot of labels. So you can if you can just label even like tens of documents. We don't need the hundreds. Like tens of documents is good enough often, or maybe like few hundreds, right? That's good enough for us to build sophisticated models that can go learn from it, and then we can then keep improving it over time. So this is something that we launched recently. Again, it's becoming available in AI Cloud. So if you're interested in those kind of use cases, talk to us. And won't be able to get to everything else, but let me hit Wave real quickly. So if you're interested, you want to try out, go to, like I said, H2O.ai/free. or come up with the website and sign up, you can then launch, get access to this, and you can try the entire platform, right? You can try all of these products. They're all available. If you want to try building apps on Wave, you can go to wave.h2o.ai directly and start trying Wave itself. Super easy to get started. Like I said, a lot of resources available. Another good place to go is docs.h2o.ai. All our products documentation is over here. So if you want to go just start reading some of these things up, that's all available. So it's a very great place to start. Okay. So that's all the stuff I had to cover today. Any questions? Anything that was not clear or like more information on?
Awesome.
Thank you, Dachi.
Great to hear that there's so much progress, you guys have made in the last couple of years.
Yeah. Last couple of years have been a whirlwind. We've gone from like just a library, like an application to an entire platform. So a lot of feedback from customers like yourself have helped us get here.
So Vinod, is everything accessible through a UI? Is there any other way that you could?
Yeah, great question. So the UI is what we looked at mainly today, but everything is doable through Python as well. Actually, do you have the notebook by any chance?
The feature store one?
Yeah.
Yes.
Yeah, if you have, maybe you can. But so John asked, like, you can do, so I can come to AI Cloud, and I can also launch, let me just go back and show you where I get this from, right? Oh, it's in Slack? Okay. You can launch what you see over here, right? This is, you can launch basically a managed Jupyter notebook. So there's an IDE on the cloud itself, so you can launch Jupyter Lab. And basically I can get, excuse me. Once I log in, I can then connect to all the different clients like Steam, Driverless AI, MLOps, and Feature Store. So I can essentially go through an entire workflow from a notebook, single notebook. So I can go to Feature Store, read features off of it, go to Driverless AI, build a model, then take the model artifact, go to MLOps, deploy the model, and see monitoring. So I can do this all from a notebook. So you can use a GUI, of course, if you want to, but there's also a full client to go do all of this automatically. Okay. Perfect. I'm going to maybe pull this out for a second so I can pull up, so it's not show my Slack to everyone.
You don't want to share Slack with everybody in the room?
Yeah, probably not a good idea, right? Alrighty. I do see it. Oh, there you go.
Yeah. Should just be the note.
Yeah, I'll just upload it over here.
If you got Jupyter fired up, you can
Yeah, I'll just upload it over here. All right, thanks, John. So this is the Feature Store notebook. So basically, what you could do over here, obviously, is once you install the basic client. Oh, let me go make it. All right. Yeah, so there's a bunch of stuff to install, but and then essentially this is the Feature Store client. You connect to the Feature Store instance. If it's running in the AI Cloud, obviously it's really easy to connect, and you can use your credentials. But once you are in, you can come in as a user. You can, what do you do typically is you can register new features. Register means that you say this is the feature set, this is the schema of the feature, this is what it looks like, and you can then ingest or push a pipeline. Basically, there are two ways to push data into the source. And once this is set up, the feature set is available. So typically what will happen, you'll create a project, and within the project you'll set up a feature set, and they'll say what are the data types, what are the schema of the feature set look like, And in practice, what will happen is this ingest step, right now it's a one-time step, but this will be driven by the pipelines that we talked about. So typically, let's say this is a Spark pipeline that goes and pulls a bunch of data files from different data sources, does some transformation, creates a new feature set, and scores it every day. And you then have that job every day pumped into the feature store using a client. So just like you'll run this through Spark or Snowflake or data, whatever environment you are. You just use those clients to push it to feature store, and feature store will just keep the increments. So every night it gets an update, it maintains the update. And nice thing is feature store will keep all the history for you, so you can go back and forth. You can see, okay, what did the feature set look like as of this date, or what did the feature set look like in this date? And you can get even a version of the features. You can say, okay, this is version 1.1 of the feature, 1.2 being let's say you added new features or you change the type of a feature. Feature set will keep the history. It will not erase it. It will create a new version for you automatically. So nice thing is you can go back and reproduce models. You can always say, okay, what did the feature look like as of this date? Or you can backtest it very easily. So we call this time travel. You can go back in time and see how the feature looked like. And once you push it in here, the feature basically is here. And then let's say a second user can come in. They can very easily just go in, log in, read the feature set as if they created it. Just like you saw in Drive, right? So I can go to the feature store and just look at all the feature sets that were created by anyone else that I have access to. I can ingest it and start using it for modeling. In this case, I can just do modeling, basic summary statistics. And once it's in Python, now obviously you can apply all the Python libraries like pandas and whatever else you want to do to EDA and modeling. Then I can connect to Driverless through the client over here, build models. I can obviously go through the GUI or do it all from the client, Python client. After I launch the model, finish the experiment, I can do one more thing. We also have the ability to take features that are created by Driverless, push it back from the feature store. So you can have basically the entire feedback loop. So that's the feature store. Yeah. So now we covered a whole bunch of things, but really encourage you to all go try it out. Let us know if you have any feedback. Like I said, it's basically a 90-day free trial. It's you can go start it, and if you need if you need to extend it, let us know. We can extend it as well for you.
That free trial includes the software and the machine time?
That is correct. Pretty generous, huh?
Do you want a completely version your environment apart from the feature store? How much else do you need to get the version?
Yeah, you can. Yeah, you can do both H2O and Driverless have a flag called reproducible. So you just when you start an experiment, you set the flag to reproducible, and then you can basically take the whole code and put it into a GitHub, and you should be able to reproduce the entire model as it is. And I don't know if maybe came late. We also now have the ability to go export an individual recipe from Driverless. So you can actually get the entire model pipeline as is, and you can then use it to rerun it and reproduce the exact same model. So everything can be fully reproducible. The entire pipeline can be fully reproducible. Yeah. Yeah.
Some of the labels were not detected because image quality was bad. So one of the use cases that I was working on was when I improve the image blurriness or contrast.
Yeah.
That improves the model. So is there kind of some image augmentation or preparation or enhancing capabilities into this?
It's a good question. I don't know if you know the answer. Top of my head.
There's an annotation app. I don't know if there's I don't know if it improves the quality, but there's a Wave app you can annotate the image.
Yeah, annotation, but still, the image quality is bad.
Yeah.
But still, it doesn't matter. So you can enhance the image quality. And
Yeah.
Enhance the maybe that feature can be added to
That's a good point. Yeah. No. Good call out. I think. Yeah. We can definitely do something like that.
There is something called TTA though that Python Torch does. It's not the same thing you're talking about, but it's test time augmentation. So actually, it fits a model, and when it goes to make a prediction, it actually makes a few versions of the image it's trying to predict the classification they want, for example, and a prediction map. So actually, it does augment the image itself, but it'll average out kind of like ensemble.
Yeah.
Right? So
Yeah. But.
same thing you're talking about.
That's a good point. I think I don't know. It's maybe it's the roadmap, but something valuable for us to add. Since we're doing a lot of automated stuff, it'd be nice to do some basic image cleanup or improvement, right? Yeah. Cool. Well, thank you all for coming. It was really nice to see some faces back in the room. It's been a while since we did one of these meetups, but we'll want to do more of these. Please suggest topics if you're interested, if you want to do deep dives on certain things. We also want to do more fun stuff, not just our products, but other things people are interested. So
You have training videos or training?
tons of stuff. Yeah, tons of training videos. Venkatesh, is the LMS live for public?
Not for public, but
Soon.
stuff that we can share.
Okay. Yeah. I'll share just like hydrogen torch, for example, has a really nice tutorial if you want to go try it out. There is a video as well, and then there is a bunch of tutorials that are like fully featured. And it's a guide for like all types of problem types, basically. Each type explains and tells you how to do that, and settings for each. So, oh yeah, I'll show you. That is a good one. So. Go to a YouTube channel. Yep. So these are some of the apps we built. There's plans for that videos. Where are the latest ones? Oh, this one. So yeah, this is a overview of Hydrogen Torch from the team itself. So yeah, there's one for each product type. So this is a full demo, walks through all the products, gives a little bit of detail from the Grandmaster team itself. So yeah, and then more of these over here. Okay. Cool. All right, cool. Thank you, everyone. Thanks, that's it.
Good job, Vinod.
Thank you.